morning, everybody. As Keaton mentioned, I'm Dan Henderson, the Director of Innovation and Emerging Technology for Caterpillar. And CII was gracious enough to invite me this morning to spend a little time talking with you about what's happening with autonomy broadly in the earth-moving industry. And I'm going to touch on that. I am going to talk a little bit about what's been happening in mining autonomy because it sets the stage for what is beginning to happen in construction autonomy. I'll spend a little time talking about automotive autonomy and the benefits that it's generating for how this can unfold in construction autonomy, and then I'll spend the balance of my time laying out for you how we see this unfolding as autonomy and the opportunities surrounding it grow for the construction industry. Just a little bit about Caterpillar in the event that you're unfamiliar with us. So we're a large manufacturer of earth-moving and mining equipment, as well as engines, natural gas turbines, and diesel-electric locomotives. We have a global footprint and we operate in all countries of the world through our dealer organization of 192 dealers. We've got about 3 million machines that are currently in service in the world today. There's about just under 100,000 people employed at Caterpillar. And a key part of our technology connectivity, we've got about 500,000 of those assets connected with what we call product link technology, which is one of the enabling technologies that supports what we begin to do in autonomy. And I do want to stop by saying or point out that Caterpillar's purpose really is to provide products and solutions that help our customers, yourselves, build a better world. And we're very committed to that. And we're committed to doing that in a way that allows our customers to make more money working with us than they can with anybody else. So to kind of give a little bit of an overview of what's happening in the mining industry and autonomy, I brought a video that does a good job of explaining the products and the systems and how that works, and then I'll follow up with a few comments after that. But before I do that, I do want to set the stage for what are the economic drivers for autonomy in the mining industry. In the first decade of the 2000s, the mining customers were going great guns to expend capital and expend both their reach and their level of activity in response to what they thought was a pretty long cycle. The global financial crisis hit in the late in that decade and put all of our mining customers under a tremendous amount of financial pressure. And at that time, they got a lot more serious about pursuing capital efficiency, pursuing productivity, operational productivity enhancements and things along those lines. Meanwhile, over the course of that time, and really in the decades prior to that, Caterpillar had been developing autonomy technology primarily targeted at mining since really the late 80s. We'd fielded our first systems with 3 mining trucks at a quarry in Texas in the mid-90s, but it really was ahead of its time. Customers weren't ready for it. In the mid-2000s, we sensed that the technologies had matured to the point where they could be available for practical use and began in earnest developing a system in response to some of our lead customers. But even through that period, they weren't too excited about it. After 2010, they became a lot more excited about it, and we became much more serious about it. Developed our system and put it in production in the 2012 timeframe, and what I'll show you in just a second is a summary of what that is, and then we'll talk a little bit about the results our customers have enjoyed as they've been able to deploy that technology.
Your mining operation faces challenges every day, like reducing costs, increasing productivity, working more efficiently and more safely. As you continue to look for innovative ways to address these challenges, Caterpillar is doing the same, making our products safer, stronger, and more productive. And we're developing technologies that not only improve the performance of your Cat equipment, but of your entire operation as well. Like Cat Command, our suite of autonomy solutions that range from remote control to fully autonomous operation. Cat Command works seamlessly with all equipment, personnel, and environments. It can help you boost safety, productivity, and efficiency, reduce your mine footprint and overall costs, improve machine availability, increase the consistency and accuracy of your operations, work safely in a wide range of challenging environments, and ultimately increase your profitability. Cat Command offerings include autonomous systems for underground, dozing, drilling, and hauling. Cat Command is a comprehensive system that delivers the full benefits of automation. We continue to find new ways to make these solutions available for every mine site, no matter the size or type of application. Even the simplest of autonomous solutions can deliver immediate productivity, efficiency, and safety gains. We can help you find the level of automation that best suits your needs and addresses your challenges. Whether you're just beginning your automation journey or whether you're ready to take the next step.
So our customers, as I mentioned, in the 2011 timeframe, we began to deploy a couple of fleets of autonomous mining trucks, called what we call autonomous haulage system, in the Pilbara region of Australia. And customers, there were lead customers, they were pretty interested, and we've been operating with those systems since and have been growing that to some degree. And I wanted to take just a little time. This is my most technical slide. I want to touch on what the technologies involved in an autonomous truck look like. And one of the things I want to point out right off the bat is it's the same suite of technologies that you will see in an automotive autonomous car that you may see pictures of or see in the news. So we have some mode lights that let the rest of the people at the site know what mode is the truck operating in. Is there a guy driving it? If the light's flashing blue, it's an autonomous mode. If it's red, then it's stopped. There's an autonomy cabinet that's got about 12 computers in it that do the autonomy layer on top of the truck. All of these trucks, in fact, all of these autonomous machines are at a base level, they're electro-hydraulically controlled machines, which allows us to have the ability to control them electronically. But then we add a cabinet that really houses the computing platform that actually makes the autonomy system work. It relies on GPS. Heavily relies on LiDAR, which is essentially a laser range-finding technology. It's got a spinning laser, and it can produce a point cloud at a very rapid rate of everything in the surrounding area of that truck. An inertial measurement unit, and then radars, which are a part of the redundancy for the technology that help sense what's around the truck. On top of this is a wide-ranging site system with a radio network and a lot of technology that actually coordinates and manages the truck. I'm not going to talk much about that. I wanted to focus on these. And I want to point out that this was attractive for the mining industry despite the kind of early low-volume costs of these technologies. And as an example of that, LiDAR applied on this truck is a sensor that costs about $75,000, which is pretty expensive. But the use case, at least with the customers that we started out with in the Pilbara, for example, it would cost them on the order of $1 million an operator per year, including all the support costs, to be able to fly operators in and out every 2 weeks, basically build a village, things along those lines. They have been having a more increasingly difficult time finding people who want to go to that part of remote Australia and operate trucks. So between those kinds of challenges they have, staffing that and the cost structure associated with that, they could afford a technology at this expense level in order to help them make the results that they're interested in making. And I'll come back around to cost when we talk about construction in a moment. But here are some of the results that our customers experienced from the use of these systems in their mines. This is a safety chart of incidents related to haulage systems at a particular customer that we deployed this in. And I really like this chart because it does a good job of showing kind of the stark difference between what a manned fleet experiences and what happened once we had commissioned autonomous haulage on that site. We've been operating for 5 years without really any serious safety incidents, and this is just an example of some of that data. Anecdotally, what we are told by the operators of these systems tell us is that they really love the predictability and the consistency of these trucks. They always honk the horn when they're supposed to. They follow all the rules, the speed limits. They're always paying attention. They never fall asleep. The way the system operates is the loading tool operators and the operators of the machines where the trucks dump are essentially the ones that control where the trucks go and how this behaves. And they very much rely on it and really appreciate the consistency and the predictability that an autonomous haulage system actually can deliver. And it's delivering these kind of safety results. On top of that, kind of across the suite of products that I talked about, these are the kind of productivity gains that our customers are enjoying in the different applications. In the mining hauling application with trucks, about 20% improvement over a manned operation, and we have line of sight to help them get to 40. Underground mining, 44%, drilling, 25%, 15% for dozing. And the dozing is not a fully autonomous system, it's a semi-autonomous system. It generally takes one operator who basically oversees 3 or 4, up to 5 of these large tractors in the type of mining push application that this has been developed for. But these have been actual real results that they've demonstrated with their own studies with our support. So the sum total of this so far, our experience has been that in the 5 years we've been fielding these systems, our customers have moved in the neighborhood of 860 million tons of material autonomously. We've currently got 129 trucks in the field. Will be more than 200 by the end of this year. As I mentioned, there have been 0 lost time injuries as a result of that. And just for a little bit of a comparison, Waymo, one of the leading automotive autonomous groups, last Friday announced that they'd achieved 8 million miles of operation autonomously on roads. Accomplishing this feat, our customers with this system have covered 18 million miles. Just to give you some idea of the level of capability that's been delivered. And by the end of the year, I think we will have surpassed 1 billion tons. So why am I telling you about mining when this is the construction group? Well, all of this is really setting the stage for the types of benefits that these technologies can deliver as it moves from mining into construction. And the other main point I wanted to make is that autonomy, full autonomy in the earth-moving industry is not some future vision. It is a current commercial reality in the mining segment. The technologies are maturing, the costs are coming down. What our customers over the last 5 years of this technology in the mining area have really been doing is answering 2 fundamental questions that they've had about it. Number one is, this technology really work, and is it going to work day in and day out in our kind of rugged application? And the second one is, can I really get value with this? Is it really going to make a difference to my bottom line? And they're pretty conservative. It's taken a few years working through the weather cycles and getting that under their belt. And it actually changes how their operation functions if they take full advantage of it. But they've answered those questions as yes. And now we're really in the phase where we're ramping that up. So let's switch and talk a little bit about construction. A similar curve, I think everybody is very familiar with this, is the overall sort of productivity curve of the construction industry for the last 50 years, and there's lots of opportunity for improvement in terms of closing the gap between sort of the rest of the economy that's shown in that black line and where the construction industry has sort of been on that yellow line. And technology, and this has been true for a while, is one way to be able to attack that. And autonomy technology will have a role in that as time unfolds. Another important trend that has been happening just in the last few years is the amount of investment in autonomy. So this is a chart that shows the amount of cumulative investment in the automotive space in autonomy. It wasn't really 0 before 2015, but it was so low, it's hard to show up on this chart. But since that time, the car makers of the world, technology suppliers have been pouring money into this, $75 billion so far to date, and that is fantastic news for autonomy in the construction industry. That LiDAR sensor that I mentioned earlier that cost $75,000, it needs to cost about $400 in order for it to be able to be applied broadly for automotive technology to scale up. That's great. This is the kind of investment that's going to drive those technology costs to a level that we as an earth-moving industry could never achieve because we don't have those kind of volumes. But we can ride right along with that, and we are working to do that. We expect a LiDAR that would be capable for construction autonomy to be in the $1,000 to $2,000 range. It requires more hardening. There are some different performance characteristics than what you would see for one that's for automotive. But we are very pleased to see what is happening in the automotive autonomy industry and how it sets the stage for what we're all going to be able to enjoy in terms of cost and capability in the construction industry in the near future. So let's talk more specifically about kind of the roadmap we see for how autonomy is likely to unfold in the construction industry. So this is a roadmap that we put together to kind of be able to articulate that. Kind of the blocks across the top are the sort of traditional building blocks of technology that all of us are familiar with and we use every day with our smartphones and GPS in our cars and things along those lines. And we take advantage of those as foundational building blocks for what we do with autonomy. Conventional construction, everybody is familiar with, is the starting point. But this is a journey towards autonomy, and it goes through a few stages with a few capabilities that become available as time goes on. And the first stage is really the beginning of automating individual functions and features on machines to make them easier to use. And then you begin to combine those things together in terms of independent features on independent machines that just working together can provide a benefit. Eventually, you get them to communicate together and coordinate more effectively to provide a benefit. And this can grow in the direction of eventually deploying a fully autonomous system. And in that strategy, from a technology strategy, we as OEMs and the technology industry partners that we work with have a very deliberate strategy of building blocks toward that technology that support those kind of functions, starting with things like machine control and guidance, which has been available in the construction industry and production for more than 20 years. As I mentioned, automating features on individual machines, remote control, some semi-autonomy, eventually leading to autonomous machines and autonomous work sites. But our deliberate strategy, and I think this is, and we get this kind of feedback also from our customers, is to deliver value with these pieces as we're on our way to something like full autonomy. You know, all of us need to be able to eat on the way to the feast, so to speak. We need to be able to deliver value. We need to be able to make a living at this. We need to increase the comfort level of our construction customers with these technologies, and the way to do that is to develop them, identify areas of value that can be specific, develop a solution for that and deploy it, and then increase our customers' comfort level with it. All the while, it's marching toward a roadmap that can build on those capabilities to eventually deliver a full capability. And I want to give you just a specific example of one that we've recently done in the excavator business. This next video is really from a customer of ours who has had an opportunity to test a pilot machine that includes a feature that automates a part of the functionality in order to make the machine easier to use. I'll let him speak in his own words, and then I'll have a few comments to say after that.
When this machine first arrived out, I was told what it would do. I was hesitant to think that that was true.
It's awesome. I love running it. It's very simple.
When I first got in it and started working it, I was blown away that you could just pull the stick and the boom in the bucket would go on its own and hold a flat grade.
I think the machine makes me look really good because a lot of it is not my work.
The technology of it is something I never dreamed that would happen.
This technology is integrated right within the CAT product line.
We're looking for simple, and that's what this machine is. It's 2D technology, but it's all contained within the machine. There's no base station, there's no satellite. It's basically the machine with a flat plane laser, and it's using the laser for nothing more than a reference. So in Utah, we're having a hard time right now. Our labor market is pretty scarce, and we're having a hard time hiring skilled operators. So with this machine, it's cut the grade checker out.
Experienced operators, those guys that have been around for a long time, that really know what they're doing, they've either retired or gone away or they're getting harder to find.
We're basically having to make operators and train them ourselves.
And technology has become more and more commonplace and more necessary for our customers in order to continue to compete in a very competitive market.
This machine here is a trainer. You can put an inexperienced operator in it and the machine will train an operator how to dig flat, how to hold grade. We started my son on this hole. He picked it up the first day. The second day he dug a basement by himself without a grade checker. I don't know that a guy with 20 years of experience could do that. I kept track of the footing guys. They said, I don't know who you have digging basements now, but that's who we want in front of us from now on. And I laughed and thought to myself, it was a kid, a 19-year-old kid, and it was the first basement he ever dug by himself.
Customers are more open to technology, more so than they ever have in the past. They are looking to us as a manufacturer and as a service provider. It really gives them the tools that they need in order to continue to grow and expand their businesses when there is such a lack of experienced and tenured people in our industry. Any technology that we have that translates to benefits in the real world, in production, efficiency, training, are exactly what our customers are looking for.
I think it could help any construction business. I would like it just to be my technology alone in the Utah market, but I think any contractor that does not see the benefit of this, they're fooling themselves.
So that's just an example of one feature that we have semi-automated in order to make that machine easier for the operators to be able to achieve their objective with it. Universally, our customers are telling us we're having trouble getting people who want to operate equipment, and the skill set, the range of skill set of those people is very wide. And we've got a lot of data from studies that we've done in the field that show that the variability of skill set of the operator is the largest determinant about whether our customers are getting the full value out of a machine. And so our customers are asking us, you need to make this easier for the machine to operate and do what we want it to do. This is an example of that. The reason I want to talk about this kind of a feature or show this to you is this is a stepping stone toward autonomy. It's built on an EH excavator. The sensing capabilities and all of that are used to do just that feature are stepping stones in that direction. And it is beginning to happen in the construction industry in ways like that. And we have a wide range, and our peer companies have a wide range of technology capabilities like that are beginning to be deployed into the construction industry that will build toward autonomy. You know, next step in the journey is really the coordination of these kind of capabilities on multiple machines at a job site in order to be able to realize a benefit to the bottom line as construction unfolds. And this next video that I want to show you is actually one that we developed to kind of make that very clear. We built a section of road at one of our proving grounds, actually two sections of the same length, one using traditional construction methods for road building and the other using the full suite of technologies that were available commercially at that time, just to do a little bit of a side-by-side comparison of it. And I want to show that to you to give you a feel for what is available for that. All of these technologies that are used in this video are building blocks toward autonomy and are setting the stage for that. So we'll watch this and then I'll have some comments about that at the end, and we'll talk about where we think this will head in the long term.
This video demonstrates how Cat Connect technology and services help customers make more money through improvements in time, cost, quality, and safety to deliver the most value from Cat and mixed fleet operations. To do that, we're going to speed up the traditional road building process. During the layout phase, a crew of workers is required to set hubs and stakes, and then calculate and publish the offsets and grades. A labor-intensive process that takes about 2 hours to complete. Next is the earth-moving phase, consisting of preparing the existing grade, earth excavation, embankment delivery, and compaction. Again, notice the number of people performing the work, and doing so near machines, which is a safety concern because of increased exposure to risk. Also, count the number of passes the equipment must make, as well as the machines and people sitting around idle, waiting for continued grade checking and work verification. It's a time-consuming manual process that often misses production targets while creating substantial rework. Customers today can also face shortages in skilled labor, contributing to even longer project durations. In this study, the earth-moving phase adds another 15 hours to the road construction project. Moving to the grading phase, spreading and finish grading of aggregate base contributes to significant checking and testing. If measurements identify inaccuracies and/or out-of-spec work, more cost and time overruns result. Too much material means additional machine passes, rework, increased cycle times, and higher fuel consumption. Too little material means extra trucking and more people and machine delays. In other words, higher costs. The grading phase takes about 9 hours. Finally, the paving phase. After elevations are verified and compaction tests are finalized, paving hubs are set and a string line installed to guide the paver. The total traditional road building process takes 29.5 hours to complete. Now, we build the same road using Cat Connect technology and services. Even before construction begins, an unmanned aerial vehicle, or UAV, flies over the area to survey the site in a matter of minutes. Let's compare the two roads. Notice in the technology-driven road on the bottom of the screen that the layout phase has already been completed in half the time. There is no need for hubs or stakes since plans are loaded into the machines, and fewer people on site means less exposure to risk. However, it's during the earth moving and grading phases when customers experience the greatest gains. Machine control and guidance as well as intelligent compaction, replace manual processes to eliminate delays and ensure that specs are met. Excavation cuts and fills achieve elevation tolerance and density targets in the fewest number of passes. With technology, operators of any skill level can work confidently without guesswork. In-cab displays provide machine control and guidance, progress at a glance, and allow graded compaction to be checked from the cab, keeping operators safe, informed, focused, and less fatigued. Additionally, wheel loader and articulated truck payload systems reduce cycle times and ensure delivery of accurate material quantities to the job site, saving time, fuel, and money. Finally, to the paving phase. Technology equals efficiency. No string lines, manual grade checking, or redundant compaction tests. The result is not only accuracy and consistency, but a better quality road in just about half the time. Here's the payoff for the customer. 31% fewer man-hours, better resource allocation, less exposure to risk, and a solution to skilled labor shortages. 34% fewer equipment hours. This results in lower maintenance and repair costs, increased machine availability, effective utilization and resale value, and extended machine life cycles. 46% fewer project hours, resulting in lower unit cost, more profit, and increased opportunity to bid for additional work, which can contribute to company growth and expansion. And 37% less fuel consumption. Another way to lower operating costs, increase profits and machine life, secure a competitive bid advantage, and reduce emission levels and carbon footprint. And speaking of that, this saves 12 acres of forest. That's the payoff for reducing greenhouse gas emissions. It's another way innovation is driving sustainable solutions for customers. So, how far down the road do you have to go until you reach profitability? The investment in new technology for this road is about $250,000. So, with that said, on a road construction project of about 3 miles in length, it takes 79 working days with technology versus the 147 working days with traditional methods. But it's still short of a return on investment. However, 4 miles is nearly the break-even point. That means for every mile thereafter, the customer is banking the profits. Customers report the road to payback using CAT Connect technology. Takes 6 months to 1 year. This investment puts them in the fast lane to less cost, increased quality and safety, and on to the next project in record time.
So that gives you a visual comparison of what technology in general is capable of doing in support of the construction industry. If you study some of CII's previous work, that aligns fully with that in this 30 to 40% range in terms of what technology can do to help construction customers, even with the things that are available now. And there's more opportunity as we move towards autonomy going forward. But there is an important key to success that I want to touch on with regard to autonomous systems in construction that we've learned in our mining experience. And first, start by saying there's been a recent McKinsey study that was put out actually in March that had this statement in it, that about 30% of that productivity gap that was shown earlier between where the rest of the economy and the productivity of the construction industry is really due to a lack of these technology gains. So we as OEMs and as technology suppliers are setting the stage to be able to deliver that value, but adopting it is what's required in order to make that happen. And what we found in the mining industry is technology like autonomy is transformational. It's not something that you're hobbying at or that you try or you turn on for a while and turn off. It fundamentally sets the stage for changing how our customers manage their people, how those people operate and execute in the processes, and even the layout of the mine in order to take advantage of that technology. Early on, in the 2011-2012 timeframe, we had 2 fleets of trucks, same technology, same parts of the world, and the same type of application, but in 2 different companies. One company basically was so bought into the vision at the time that they designed the mine around what they were planning to do with autonomy and fully embraced the fact that they were going to need to design their people and processes around that. and they're the ones that got that 20% benefit. Our other customer did not go quite as far and really tried to adapt or deploy technology into an existing aspect of one of their mines, and they didn't experience those kind of benefits. And we studied that quite a lot to really understand, well, what were the differences between that? And it really had to do with being able to attack these three things. As an OEM, we can help you with the technology. We can actually help with the people and process, but it's actually the management and the owners of our customers' businesses that have to understand what their needs are, and then have to be willing to adjust and adopt that in order to take advantage of it. And in our view, this roadmap that we show and the time frame it's going to take to get to more full autonomy in construction is totally being paced by the adoption rate, the desired adoption rate of our construction customers. And we're very interested in helping people adopt more of these technologies and realize the benefits that come with that as we move forward. But my appeal to you is, in order to do that, we have to work together to identify where the best value is, and then work with you to begin to get comfort level with deploying these technologies and building on that as we go forward. I had been asked while we were preparing this material that I should come and set a date for when this is going to happen. I told everybody, no, I'm not going to set a date. It's impossible to know. But what I would tell you in my mind is, full autonomy is a commercial reality today in the earth-moving industry, and we are proving that technology day in and day out in mining. All of that work, it will benefit the adoption of it into construction. Automotive cost, those drivers are going to lower the cost to make this attractive, so it won't cost an arm and a leg to be able to do it in construction, and we're pursuing that. We have a number of developments that are happening in our pipeline that over the next few years you'll see more of the kinds of features that I showed on that excavator that will be delivered into customers' hands, helping them to gain more value and to move forward in this direction. And then we look forward to a bright future as our industry learns how to adapt and adopt these kinds of technologies for the benefit of your businesses and the benefit of ours, and ultimately for the customers that we serve. So I wanted to leave about 10 minutes for questions, and I think we've got just about that. I think Keaton's going to come back out with the app, and feel free to ask me any question on any part of this subject.
Thank you, Dan. Very good presentation. Thank you for that.
Thank you.
And also, I should have mentioned you guys are doing a great job, but definitely as the speaker is speaking, please continue to use the app to ask the questions. So we did get quite a few on this topic.
Great.
So let me start. I'm going to put you under the spotlights here
Perfect.
again. First of all, how are people impacted by the advancement of autonomy technology? So again,
In
really
terms of
people.
employees?
Correct, right.
So this is a general autonomy issue, and beyond just this, that there's concern that it's going to displace people. How is it going to affect employment over the course of time? Our experience has been there's not been any negativity associated with that. As I've made mention, our customers are clamoring for us to help them with their labor shortages. For whatever reason, younger people, millennials, are not really attracted to operating earth-moving equipment as the career of choice, and they sure are not attracted about doing it in the middle of nowhere. But they're very comfortable playing with what amounts to a video game. And several of these autonomy technologies are remote control capable, or the way that it actually works is, instead of the operator sitting in the tractor running the tractor, the operator is at a control system that looks like a tractor with the tractor operation, and he can just hit the screen in front of him to pick which tractor he wants to be controlling, and he's doing that. I mentioned our semi-autonomous tractor system. That application for those tractors, when those guys are on those machines, those machines are operating on about a 40-degree slope. They're in that tractor 10 hours a day, and that means they're basically almost having to stand up in the seat, and it's a rough ride for 10 hours a day. And these guys, where we developed this technology with that customer, they're people with 20, 25 years of experience. Now, they sit in an air-conditioned trailer with the seat and the controls, and they oversee the management of about 3 to 5 of these tractors, and they love it. In their view, their job just got upgraded and became something that, to be honest, they could actually sustain until they're 65. Whereas on the machine, there's a point at which that gets pretty tough on the body. In the mining sector, it's been a similar sort of a situation. It changes the role that people have, but it elevates the roles of the operators that are actually associated with it. And so the feedback that we're getting is a pretty wide acceptance everywhere from the craft up through management.
Okay. The next question focuses around the timeline. So is there a specific timeline in mind for full autonomy deployment in the industry? And there's also an add-on question which I want to talk about. It talks about the cost of LiDAR being high. So is that one of the barriers to the full autonomy deployment, the cost of LiDAR, and when do you see that
Cost of the
reducing?
technology in general has been a barrier to deployment. When your LiDAR costs twice as much as your skid steer loader, you know that's not going to work. And we do not have the volumes in our industry to drive the cost. The automotive industry really does. We've seen this for quite a while. We've been working the technology, even with the expensive technology, for construction applications, knowing that there will come a time in the not too distant future when the cost is right. The timeline of adoption, as I mentioned at the end here, is totally dependent on our customers and their ability to really take it on. The technologies are being deployed. In our view, it's no longer a technology question or whether it's going to work or whether this is going to be able to really happen. That has all been proven in the mining industry, which has got more rugged environment than most of the construction industry. And we're positioning it to be able to do that. The key is identify where the value is and deliver just enough autonomy to the customer to satisfy that value and no more. But that's a partnership with the customers. So it's starting now in our minds. It's not in the distant future. When will it finish, and will it ever finish with a fully autonomous construction site? We really don't know the answer to that question. Even as we're deploying autonomy in the mining industry, we're now moving on to other applications. Those are new applications of autonomy where we develop the feature sets and whatnot that go with that. And that's how this works, is even though you have the basic autonomy capabilities, you work with the customer to understand what problem they have to solve, and you develop the software and systems that allow us to apply that to solve those problems. And that adds to the overall capability of the system. And that's exactly how we think this will unfold in construction.
Okay. The next question is around how quickly this technology will emerge or progress. So how quickly can we expect to see the next level of autonomy be commercially available in the construction industry?
We have development programs, product development programs in the works now that we expect in the 2019, 2020, we're going to begin streaming out more of the kind of features that I showed on that excavator. We have product programs that are working on that now. But I will say, we will only do those if customers are willing to buy them.
Right.
I mean, I know we aren't doing it for the fun of it.
Business,
yeah,
right?
it's a business.
Yeah, it's a business.
And I'd incidentally also say an interesting thing in that study that I referenced with that quote, that same study asked 600 construction contractors questions about prioritizing maybe 5 or 7 choices of technology, one of which was full autonomy. And the construction contractors basically said, full autonomy is at the bottom of our wish list, which we're a little surprised at, but it really gives a feel for nobody is in love with the technology. They need it to solve a problem, help become more productive and more efficient. It's really cool, but that's not why we're all doing it. We're doing it because we can really help ourselves be more effective and be more profitable through its deployment.
Well, there's one question specifically asking about that productivity and kind of challenging it. It says, looking at the productivity chart, the 20% or 44% is not going to get even close to the productivity that other industries have achieved. What else is missing, or what can we do to try
Well,
to
that productivity gap and that technology statement were not just about the earth-moving part. That's the part that I'm kind of covering at the moment. But if you go out, even among the people in the booths here at the conference, there is a wide range of technology solutions that are trying to attack is the wrong word, but transform different aspects of construction. Those things taken together can make those kind of differences. But there is no magic bullet. I mean, there's not going to be one killer app or anything like that. It really is a combination of technology being available and then customers understanding how to adopt it and how to adjust their people and processes to take advantage of that as they grow to be more efficient.
Sure. Okay, one of the questions asked, do you foresee a center where Caterpillar will operate machines for multiple clients remotely? So perhaps a centralized function for this type of activity?
Our big mining customers are moving in a direction of having large centers in large cities that operate their mines distantly, like more than 1,000 kilometers away. They're asking us to help with that, but those would be theirs. In the construction industry, we foresee that we will be hosting, sort of like we would own the cloud, if you will, for the servers and all that, for all the software that's around at a site system for that to happen, and that customers can access that, so it can scale from very small customers up to large ones. That's stopping short of us actually operating the equipment or operating or using the system to accomplish a task. We expect that the customers will still be doing that. We are positioning ourselves so that we can host that and make it as easy as possible to lower the barriers to adoption, even for the smallest type of construction contractor as time moves on.
Okay. Another question here relates to an actual practical field application. And it says, how will autonomy technology deal with unknown underground issues discovered during the excavation? Issues like pipelines, contaminated soil, et cetera. We all tend to run into those type of things.
Well, this is why full autonomy is difficult, because there is a wide range of problems to be able to solve. We have work going on with technology development work with ground penetrating radar and things like that, but that's a really tough problem to solve. To the degree that those kind of advancements can provide insight to that, we'll take advantage of it. But that's a great example of where an autonomous system with the current technologies may not be able to stop that,
Sure.
or there'll be other ways that we have to work to stop it as opposed to directly sensing it. But the whole world is actually working on things like ground penetrating radar and ways of seeing what's below the surface. And as that advances, we will take advantage of those sort of capabilities to help improve the capability of an autonomous system.
Okay. Another technical question. I know that's your background. So discuss data interoperability, taking 3D intelligent model data imported into the CAD systems, and then can as-built data be sent back to the 3D model? Is that?
Yes, and that actually happens today. Between the UAV type surveys, all those machines that are equipped with machine control and guidance today produce as-built information that can be sent back and integrated into the 3D CAD models of a site. That happens today and will continue to happen in the future. Where we're at right now with autonomous systems that have LiDAR is something called situation-based perception. So those LiDAR systems basically are taking a point cloud of every surface that laser touches, including the ground. And we are working on ways of being able to take that information and use it to represent a part of the as-built view in real time that would be sent back to the office. But it requires a huge amount of computing horsepower. But that's kind of where that's headed, so that every machine that's not only driving over it, but it can see it with a LiDAR, that just adds to your updated knowledge in real time of what is actually happening on a site.
Sure. One question or multiple questions here on the security of this technology as we evolve with the technology, with the vulnerabilities of being connected. What is CAT doing to prevent breaches, considering the massive impact of a compromised uranium or oil and gas refinery?
Yeah, that's a great question.
So.
I deliberately didn't come here to talk about the technology, so I don't have a lot of slides on that, but cybersecurity is very high. Just physical security of the site and then cybersecurity are two of the pillars of how we've architected our systems. The electronics on our product that support autonomy are architected in such a way that that they could be attacked. You have to physically get near the product, you'd have to get the box, and you'd have to work on the box to attack it. And if you were able to hack into that one box and found the key to that box, it won't work for any of the other boxes on any of the other machines. So, there's actually export controls over the level of encryption that you can export from the US. We have built into our products, these newer products, the level of export of encryption and that kind of security capability just short of what you can be export restricted for, similar to what an ATM is or things kind of along those lines. And then we have multiple layers of that. There's 7 layers of safety related to an autonomous site that we put in place to ensure that it can't be attacked, and that physically you're not going to hurt anybody as it operates.
Sure. Okay, and one final question for you, and this really talks about the density and equipment of equipment and people on a job site. So on a construction site, that can be much higher than in a mine. So is this a limitation right now in terms of autonomous operation or autonomous vehicles?
We believe, and there will be fundamental sort of architectural differences between a process customer like a mine, which is a closed site doing something at the same basic area for 4 or 5 years, and a project-based construction site where you have all kinds of people coming in and out and you can't control that. A construction site's going to be a lot more like autonomous cars running around kind of in the wild. And we're working to change the architecture of autonomy for construction to be able to anticipate that. The sensing systems and the capabilities are capable of dealing with that kind of variety as time goes on. But working together with that technology capability and how customers intend to manage it is a part of where we're actually working now to best understand how to strike that balance. It is a much more dense application. It's much more unpredictable with a lot of other people that are coming and going. And we absolutely want to make sure that the systems are safe. What it will amount to is that the machines will take on a lot more of the full capability of autonomy and will be less reliant on overall site systems. The site systems will still give assignments, but the machines, even on their own, will be fully capable of operating autonomously, similar to what the rover does on Mars. You know, you give it some commands, it goes and does its thing, and then make sure that it does it in a safe way.
Very good. That was our final question.
Great.
So appreciate the talk and
Thank you.
appreciate your input. A lot of questions on that topic, so thank you very much.